New research, just published, means that we're going to have to think again about one of the basics of human reproduction, and it could also help people who are having trouble with fertility to conceive. The new results relate to sperm and what up to now has been known about the way in which they swim towards the ovaries to fertilise eggs. No doubt you'll have seen movies of stereotypical sperm wiggling around a bit like tadpoles in a pond. The head of the sperm carries the DNA, and the long tail or flagellum lashes backwards and forwards to propel the sperm along. That motion was first described over 300 years ago by the Dutch businessman and scientist Antony van Leeuwenhoek, using one of the earliest microscopes that he actually helped to invent. But now, using more modern technology, a joint team from Britain and Mexico think that we might need to rewrite the textbooks, as Eva Higginbotham heard from Hermes Gadea.
So this equipment is a normal microscope, but that is able to solve two challenges. One, the sperm is very small and in the micrometer scale. So the length of the flagellum is about 50 micrometers. This is about half of your hairbreadth. But at the same time, the sperm is also able to beat and move very fast. So about 20 to 30 swimming strokes can be produced in one single second. So we needed to create an experimental setup that was able to scan the cell in the time scale in which the cell appears to be at rest, that is not moving.
So it's like if you tried to make a movie of a hummingbird. You're taking pictures very, very rapidly, one after another. And by doing that, you can reconstruct the movement that's occurring.
Precisely. We need such a high-speed camera that this camera is able to take 55,000 frames per second. The additional complexity is that the sperm is moving in 3 dimensions. So you have to move your focal plane, so the place where you take the picture, up and down really quickly before the sperm changes shapes again. And you compose your 3D movie out of the combination of all these slices in time and in space. So it's what we call a spatial temporal description. Then when you look at the movie in 3D and you look top down, what you see is that the sperm moves as you would expect, from left and right. But this is not the true beating of the tail. For you to see how the sperm is beating the tail, you need to move to the reference in which you swim with the sperm. And to do this, you need to use mathematics. Using mathematical transformations, we can change the perspective. Imagine that we could make a miniaturized version of a GoPro and it's stuck in the sperm head and the GoPro pointing to the tail. This would reveal the true motion of the tail. What you see is that in no moment the sperm tail is beating left and right, left and right. It's just beating to one side. It's beating asymmetrically. It's like wonky. And that was a big surprise. The bending on the tail is only happening to the right, but this also has an out of plane component that makes the sperm rotate around itself. So this causes the sperm to roll as it swims. And the combination of the sperm rolling with the asymmetric beating balances out this asymmetry. So that effectively, when you look from outside, the sperm is like it's beating symmetrically from one side to another.
I see. So it's beating to the right, but it's also rolling to the right. So when you just look down a microscope, it looks like it's going left, right, left, right, left, right, but it's just rolling.
Exactly. So the sperm is like twitching, let's say, to one side, but with a very clever and coordinated fashion in such a way that the rolling motion compensates exactly this asymmetric beating. So the sperm is able to create symmetry out of asymmetry, but in a very complicated fashion.
University of Bristol researcher Hermes Gadea, and his research is in the journal Science Advances.